Hello, is this thing on? Anyone there? Eric's here. Hi, Eric. Who else is here? Let's see. Hi, everybody. I'm here. Jimmy's here. Nicole, good. Here, I don't want to be the bad guy here, but I need take a look. Okay, if we look at our course and we look at our updates, it looks to me, if you take a look right here, there's only three people that posted anything. Now, I did get a couple emails from people, okay, but remember, as you're trying these problems, I want to go over ones that we need to work on. I want to go over ones that you have questions on, okay? And we're going to try something new since we're practicing. We got 3 weeks left. We're practicing for the AP test. Let's see if this works. Completely up to you if you want to participate in this. But what I want to do is, let's go today. We'll try it today. The AP test is at 1 o'clock. Okay? So what I want to do is just to practice this, not every day, but maybe once a week, twice a week. Okay, at 1 p.m., I will post an AP question on Schoology. Okay, AP question, I'm going to post that on Schoology. Okay, and you will have 30 minutes to work on it. It'll be out what I think, and it's just my opinion, but what I think a good AP question is. So I'm going to post an AP question at 1 p.m. today. Okay, now if you, it's all optional. Well, everything's optional. I'm not going to drag you out of your bed, but look at that. A lot of people are here now. And then you try that problem for a half hour. And then at 1:30, we're going to Zoom. Now, I'm not going to do the problem for you. I'm going to watch you do the problem. I'm going to say, who wants to do this part? Who wants to do this part? Who wants to do this part? So at 1:30, so you got to shower. Look at Mr. Noah's all clean. I'm still in my pajamas, but then we'll Zoom at 1:30. I'll have the link up for Zoom. And then I'm going to call on you, and you do this problem. And that I could see how you're doing. I could see what you're working on. And we'll try it today, see if this works. And see who wants to participate in it, see how many people want to participate through if you have time. Now, if you're not there, I'll still post a question at 1, and then maybe around 2 or 3, I'll post the answers. The problem worked out, so at least you could, try to work out the problem and stuff like that. But let's try and see how this goes and see if that is anybody, their first instinct. Anybody think that that's, might be something nice? I mean, we do have a lot of people here. So anybody think, because I chose one. Well, here's the problem. I teach now, and then like around 9:30, Mrs. Noah and I, we have to teach our kids. So we teach our kids from 9:30 to about 12. And then Mrs. Noah teaches from about 12 to 2 to her students. And I picked 1 p.m. because then my kids are done and they're playing on their iPads for the next, 12 hours a day. I got to kick them out of the house to go outside and play with stuff. But Mrs. Noah thinks there's cougars out there that are going to attack our kids and mountain lions. So I got to be out there with them. But I figure I could get away at 1 p.m. to 1 to 2. I'll post the question up there on Schoology, and then we'll Zoom. You'll have a link of Zoom that you could get to me on at 1:30, and then we'll go over it, and we'll see how that all goes, just so we can have some interaction. And not every day, because the school says you guys are too stressed out about. But we have 3 weeks left, so let's practice this maybe every couple days, twice a week or something, and see how that goes. So that is the plan. We'll have a little plan today. But let's go over some of the questions that people have. Now, remember, your grade, take a look. Your grade is you have to post questions or email me and say, hey, these are the ones I want to go over. And we'll still go over this on Friday. And tomorrow, Thursday, remember, I will post the answers up. And all you got to do for a grade Thursday is to check the answers. Check your answers with what you've been working on. But I'm going to go over the people that people have asked already. And so we're in 6.4. So everybody look at your 6.4 work. Right, 6.4, right there. Oop, that's the turn-in work. 6.4 problems. And people were asking about 2 and 3. So let's look. We did number 1 on Monday, so hopefully does everybody feel okay on number 1. But let's go over 2 and 3. All right, so what do we want to do? Look at number 2. We got a function, f of x. F of x is equal to, sorry, old man eyes, I got to enlarge this here. F of x is equal to the integral. So function is an integral, okay? The function just happens to be an integral in there, just like a function happens to be an addition problem or whatever. A function is an integral, a summation, dt, okay? And g of x is f of sine of x. So that means I'm plugging in sine of x in here, okay? So it says find f prime and g prime, okay? So let's keep them separate. Okay, f prime, I have to take the derivative of an integral. Okay, so remember the plan. We had a nice little movie. Let me change colors here. This 3x flies in and replaces for the t times the chain rule times chain rule minus the 0 flies in there times the chain rule, but we all know the derivative of 0 is 0. Any constants are not going to matter. Okay, so f prime of x is equal to, remember here comes the derivative, hits the integral sign, blows up, square root of 4 plus, and that 3x gets plopped inside there, times the chain rule, times 3. Now remember, not the chain rule of what's in here. X is the variable, the chain rule of x up there. Okay, x is the variable. So times 3, the derivative of 3x is 3. And then minus, but derivative 0 is 0. There's f prime of x. Okay? Did everybody do okay on that? Now g prime of x is the derivative of here. Okay, so we want g prime of x. G prime of x is f prime of keep times the derivative of sine is cosine. You see that? Now you want to get rid of the f prime. Well, we got f prime right up here. Okay, so g prime of x is f prime of sine. Everywhere I see an x, I'm plugging in sine. So square root of 4 plus, I'll square it, 9 sine squared of x. You see? I see an x there, I plugged in sine. That's how it works. That's how it's been working since Algebra 1. Times 3. Let me put that 3 right there. Times cosine of x here. So let me cover that cosine of x we're not worried about. I just plugged in, wherever I saw an x, I plugged in sine of x. So right there. And everything else I just copied down. Square root, 3, the 4, the plus, everything I just copied down. And then cosine. Right there. There is number 2. Everybody see that? Okay. How is that? Anybody? And let's do number 3 also. Some people are asking about number 3 in this section. So on what interval is f increasing? Okay, so they said capital F, this is number 3 in 6.4. They said capital F of x is the integral, again, fundamental theorem. See how we're practicing fundamental theorem right here. Sine of t squared dt. Okay, we're practicing fundamental theorem. So I take the derivative. How do I find increasing? In function, remember the synonyms. You should have that chart right there. Wherever you're going to work, here's my workspace. I should maybe even make posters all around your space and say, oh, these are the synonyms. The synonyms maybe put right there on the wall right there. What are the synonyms for increasing? Oh, function's increasing, the derivative is positive. What are the synonyms for concave up? Oh, function's concave up, the derivative is increasing, the second derivative is positive. Just have it right there, ready to go to look at, because you're not going to have enough time, and that's what we're going to practice on these AP questions. You're not going to have enough time to flop around trying to flip around in your binder. You have your tabs ready to go, or just have stuff all laid out. But remember, too much might not be, very helpful. Okay, that's why the binder should be just the facts, the important stuff right there. So we want to find when this is increasing. That means we got to take the derivative. F prime of x is, all right, remember, same thing. Here comes the derivative, hits the integral. This is the derivative of an integral. I'm not going, can I think of a function whose derivative is? I'm not integrating a derivative. I'm taking the derivative of an integral. Remember, always tell yourself that. So this x just flies in there. X squared times the chain rule, 1 minus 0 times chain rule 0. There is f prime of x. You see that? So when is something increasing? When this derivative is positive. So we make our little number line. Let's try to find where it equals 0 first. That's the easiest. Where it's equal to 0, between 0 and 3 inclusive. So here's 0, here's 3, here's capital F prime of x. And there's no way you're going to solve that by hand. Okay? So you get your calculator out, and let's set the window. Okay, first of all, let me clear the old stuff out. And we got sine of x squared. Sine of x squared. And go to your window first. Our window is just between 0 and 3. And we want to find where it crosses the x-axis. So I'm only going from, say, -2 to +2. Don't care about any of the other stuff. Let's see what happens. There, it looks positive. Oh, looks like it crosses there, and still at the end. So it looks to me that this point right here, whatever that point is, it's positive there. And then from here to here, it's negative. And then from there, it's positive again. And so we're asking for its f where it's increasing, so we got to find these intersections. Remember how to do that. Now remember, they said on the AP test, they said you will not be required to use a graphing calculator because they can't guarantee every kid that's taken the AP test has a graphing calculator, but you were comfortable with the graphing calculator, so you should use it. And so find the second and find the 0. And like I said, we're doing this 0 first, so remember how it works between there and there. And this 0 is 1.772. And then do the same thing, second calc, find the 0, and move the cursor over to that spot. Can you really see that okay? And just get between there and guess that. And now we're at 2.5066. 2.5066. Remember, you could always do this on your own now that we got it. Why didn't you make it times 2? You mean the chain rule? I don't understand, Jimmy. Why didn't you 2x? Oh, okay. Remember, like up here. Remember, we never take the derivative of this. This is what we're taking chain rule for. The chain rule is always in the bounds. Okay, so remember we had a little movie. Here comes the derivative. It hits this. It never makes it to sine of t. Sorry. X is the variable. So my chain rule is the chain rule of x, which is 1. So I could say here comes the chain rule times 1. Here's all the extra stuff that's involved that I didn't show, minus, and then I plug in the 0 squared, but times 0. There's the chain rule again. You see? So you can't look at this. You say, I am taking this derivative. And how do I take this derivative? This x flies in here, times the derivative of the x. Now, if you want to take the second derivative, then we're going to times the chain rules inside here. But we never made it into sine of t squared. And so where is this function increasing is between 0 and 1.7, and then again between 2.5 and 3. Make sure you always go to 3 decimal places. That's good. You got to ask a question on anything that you don't know. And the only way to ask a question is to have tried them first and say, I was stuck on that. And I'll post the answers tomorrow so you'll know which ones you're getting wrong. And then on Friday, we'll be able to go any ones that you got wrong. Let's go to same section, number 10. People are asking about number 10 because not many people posted anything. Evil glare. All right, so take a look at what we got here. Again, we're practicing the derivative of an integral. Okay, so take a look. Here's the function, number 10. And we have g of x, here's another example, Jimmy. G of x is the integral from 0 to x of f of t dt. Okay? And first of all, we want g of 4. So I'll plug in 4. G of 4 is the integral from 0 to 4 of f of t dt. Now remember, how are we going to evaluate that integral? Again, should have a poster. We have 4 ways to evaluate an integral. I guarantee that's going to be there. Should we use a table? Should we use known geometric? What should we do? Oh, look, the problem gave us a graph. So I'm going to use known geometric. What do I have to remember about known geometric? It should be right there. Below the x-axis, I'm integrating from 0 to 4. Below the x-axis is negative. And then we got to remember the bounds, and the bounds from smaller to bigger. All right, so think about, look at the graph, everybody. Look at the picture here. Look at the picture. Let me get the bigger picture so everybody could follow along with me. Look at your picture. That's not a bigger picture. Hey, that's me. That's me watching me watching me. Hold on. We don't want that screen. Change screens. Not that screen. We want this screen. This one. All right. So look at the picture. 0. So this part of the integral right here, take a look. This part of the integral right here is negative. This part is positive. This area cancels with this area. I'm saving myself some time here. So the integral from 0 to 2 should be 0. So all I really have to worry about is 2 to 4. Between 2 and 4, I got a trapezoid. Or you could think of it as I have a rectangle and a triangle. So this rectangle, base of 1, height of 2, so that's 2. The triangle, base of 1, height of 2, divided by 2, though, so that's 1. So that gets me, back to my document, that gets me, oh, I got too many screens going here. That gets me, this is equal to 3. Now, did you follow that? Notice how quickly we could do this. You didn't have to. You had an area below the x-axis that you got to remember is negative, and it cancels out with the area above, the symmetry right there, which is positive. Is that okay? And then it says let's find g prime of 4. All right, that means we've got to take the derivative. Here's another example, Jimmy. I'm taking the derivative here. The chain rule will be on the x. So I always think chain rule there. That's a 1. That's a 0. So g prime of x is equal to just f of x. Don't forget the x flies in there. And so g prime of 4 is f of 4. And I'm looking at the graph. What's f of 4? F of 4 is 0. So g prime of 4 is 0. You see that? And then g double prime of x is f prime of x. Again, what represents f prime of x? If I have the graph of f, f prime is the slope. Does that make sense? And so g prime of 4 is f prime of 4 is the slope at 4. Let's look at the graph again. What's the slope at 4? The slope at 4, oh, lucky me, it's a straight line. The slope at 4 is rise over run. I went down 2 over 1. So the slope at 4 looks like to be negative 2. That's a great problem. I had covered a lot of stuff there. Let's go over it one more time. I got g of x is an integral. So the first thing I did is I plugged in 4, and I have to integrate that. Now, this again, it's a good problem because remember, you only got 2 AP problems. And this is covering integrals, this is covering derivatives, this is covering second derivatives, this is covering a lot of stuff. Okay, so I plugged in 4. I have to find the area. The area was 3. Then I take the derivative using fundamental theorem of calculus. So then I just have to look at the values of the graph. And then I took another derivative, so now I have to look at the slope of the graph that's given to me. You see? So that's a lot of good That's a good problem there. Rayanne wants to do number 7. Let's do number 7. Let's go up here. Problem 8. Problem 7, right there. Problem 7. Okay, so again, we got a function that has an integral in it. There's y. They want us to take the derivative. All right, let's take the derivative. This is good practice of fundamental theorem here. I have y equals 5 plus the integral from 2 to 2x of e to the negative t squared dt. Now, right away, here's what Jimmy was saying. Right away, there's going to be chain rule. Not because there's chain rule in here. This has nothing to do with chain rule. The chain rule will be up here. So we're going to have to say times 2 when we're done. So take the derivative, dy dx, is equal to, well, the derivative of 5. What's the derivative of 5? The derivative of 5 is 0. Plus, here comes, I want a derivative of this integral. So this e to the negative, see how I leave the t out? And this flies in here and goes 2x times the chain rule of 2. There's the derivative. Okay, so right away, let's see which one. Which one? Look at A and B. A and B right away just didn't plug in 2x. So that one's out. C forgot the chain rule. You see, they don't have this times 2. So D and E are the only possible choices right there. But look at where the mistakes are. The A and B people, the people who picked, let me put it up here, it's bigger. The people who picked A and B, all they did is they just dropped out the integral sign. The derivative cancels the integral. That's incorrect. You got to take the bounds and fly them in there. C forgot the chain rule of the bounds. The bound is 2x. The derivative of 2x is 2. That's what they forgot. So we're either D or E right now. Now it's like, well, when I plug in 0, do I get 5? When I plug in 1, do I get 5? Okay. How do you plug, hold on, what did I say? How do you plug in the bottom? Well, remember, you do plug in the bottom. Let me show that. Let's go back to my document here. You do plug in the bottom. I'm going to change colors because technically it's minus. So you plugged in the top times the chain rule. Minus, now you plugged in the bottom, but watch the idea of the bottom. Now make sure you understand this. Instead of the t, I plug in the 2, but the chain rule of the bottom, the chain rule of 2 is 0. And that's always the case for a constant. Anytime there's a constant on that, the chain rule is 2. You see? So I did plug in 2, but times the derivative of 2, which is 0, and that's always going to cancel out. If it's just a constant, that's always going to cancel out that part. You see what I mean? The top was 2x. I plugged in 2x times 2 for the chain rule. Minus, the bottom is 2. I plugged in 2, but times 0 for the chain rule. What's the derivative of 2? 0. So that's always going to drop off that term right there. You see? So that's why I say if it's a constant, that's good, because the constant, the derivative, if you're going to take the derivative, not if I'm just doing a regular old integral, if it says take the derivative, like this problem said, that plugging in the 2 gets me a 0. Okay? So our choices are between D and E. Okay, so it says, let's say plug in 0, plug in 1. When I plug in 0, y of 0 is 5 plus the integral from 2 to 2 times 0 of e to the negative t squared dt. And y of 1 is equal to 5 plus the integral from 2, and I plug in 1 to 2 of e to the negative t. And again, here's why this is a nice problem, because which one of these cancel? Without a calculator, there's no way I'm going to integrate this. But I know what this answer is. What's the integral from 2 to 2? The integral of 2 to 2 is 0. Okay, so that's gone. Notice, I'm not even talking about plugging anything in. I know the integral from 2 to 2 is 0. And so y of 2, or y of 1, is the 5. Y of 0 is 5 plus some number. And the calculator can tell me what that value is. But y of 0 is not 5. y of 1 is 5. So the answer is E on this one. Everybody okay with that? Yeah, E. All right, Hunter said, let's do 11. Now remember, just stop me. I'm just, because there's a lag. I got a 10-second lag. I'm looking at my timing here on my live timing, and I'm looking at the timing for you guys. I got a 10-second lag. So don't like, oh, you moved on. I'm going to stop typing my question. Always type your question. But we're moving on to number 11, he said. Let's look at 11. Can you repeat why it's E again? All right, well, first of all, are we okay that it's between D and E? And so D says plug in 1. Oh, what number was this? Where is it? I forgot what number it was. No. Back. 7? Is it 7? There it is. D says I plug in 0 and I should get 5. E says I plug in 1, I should get 5. You see, both derivatives are the same. Okay, so when I plug in 0 for x, remember we're not plugging in for t, we're plugging in for x, f of x, or y of x in this case. I plug in 0 for 2 times 0 is 0, I get 0 up there. I plug in 1, plug in 1 up there, I got 2 times 1 is 2, I get 2 up there. So now we got to say, how are we going to evaluate these two integrals? You see, we got two different integrals. Well, right away, I should be able to look at that and know from 2 to 2, the bounds are the same. So that's 0. So this is 5 plus 0. This is 5 plus, I don't know. I don't know what the integral, I have to use my calculator to figure out what that integral is. But I know that integral is not 0 because I'm going from different numbers here. You see? So the question is, what's y of 1? Well, E says y of 1 is 5. And D says y of 0 is 5. Well, y of 0 can't be 5 because it's 5 plus something else. So you have to recognize the bounds and see which one those are. Let me go to 11. Let's see what 11 says. All right, 11. Nope, it's not 11. There we go. Find 11's part of this graph here. So make sure, yeah, we have this graph of f of x. Always make sure you know what's the graph is shown. And again, the whole point of this whole section is fundamental theorem. H of x is equal to the integral from 0 to x over 2 plus 3 of f of t dt. And then it says, find for 11, says h prime of 2. So we got to take the derivative, h prime of x. All right, let's answer the question. When I plug in, here's what Ram was asking about. When I plug in 0, is that going to produce anything? No, because of the chain rule. I'm taking the derivative of this. Even if this was a 10, that's still, that part's going to be 0. It's going to be plug in this top number times the chain rule minus plug in this bottom number times the chain rule. And because of that times the chain rule, that's always going to be 0. I plug in, if this was 100, whatever this bottom, doesn't matter what this bottom number is if it's a constant. If there's an x on there, then that's going to have chain rule, and that's going to matter. But this, what doesn't have to be 0, could be 10, could be 100, could be whatever. Let's take this derivative. First step, plug in this top number. This top number, remember, flies inside there. You see? Goes inside there, and then times the chain rule. 1/2. Don't do quotient rule. You got to think of that. Just a fraction. It's okay. It's 1/2 x. Maybe you want to write it as soon as you see a fraction. If that's bothering you, just write it like that. It's a linear times the chain rule. And then let's use a different color. Here's what Rayanne was saying, minus. I am going to plug in 0, but times the chain rule is 0. So that cancels 0 times whatever is always 0. So that's not there anymore. Okay? So h prime of 2, it said, plugging in 2, right? H prime of 2 is, I plug over f of, notice I didn't even look at the graph yet. I'm just plugging in 2. 2 over 2 is 1. F of 4 times 1/2. Now I'm going to look at the graph. F of 4 looks like to be negative 3. See that? F of 4 is negative 3. So h prime of 2 is negative 3 times a half. Oops, so negative 3 halves. This is good fundamental theorem here. Okay, how's that part? All right, did anybody have another one? This is 6.4, but did you try the other worksheets? Remember, we have a couple more up there. These are the ones people asked about. There's 6.6 and 6.7. Take a look at 6.6 and 6.7 sometime today. Okay. Can you explain the last part? You mean the part of, hold on, which is the last part? The one where this the red right here. Okay, because remember, if I look at the red's gone. That's what Rand was talking about. And then now I'm just saying, now the problem says plug in 2. They wanted h prime of 2. So I plug in 2 here. I get 2 over 2 plus 3. I get 4. And so then I just look at the graph. Since the data was given to me in graph, I find f of 4. Take a look right here. F of 4 is negative 3. So I plugged in negative 3 right there. And times 1/2 because of the chain rule. That's where I wind up with that. How would it be solved? The problem if the bottom isn't a constant. Well, if the bottom's not a constant, let's say the bottom was, I'll just make something up, 4x. Let's say the bottom was 4x. Then this derivative would be f of, plug in the top number. Let me write I get a sheet of paper here so it's not messy. I plug in the top number. Let's say it was h of x is the integral from x over 2 plus 3 to 4x. Let's say it was something like that. And same question. I want h prime. Let's say I want h prime. Okay, so I'd plug in the top. I'd say the derivative here comes the derivative. I'd plug in the top f of x over 2 plus 3 times the chain rule 1/2. Now minus, and I'd plug in that. F of 4x times the chain rule 4. You see what I mean? If they both could be different things. The only reason why one of these, see, there's two terms right here. Here's plugging in the top one, and then here's plugging in the bottom one. And the only reason why one of these go away is if one of them's a constant. So if one of them's a constant, let's say the top is a constant, then let's say top was just like 3. So it'd be f of 3 times 0, so the black part would go away down there. And it'd be 0 minus f of 4x times 4. It's just on our example, the bottom was a constant. Since the bottom was a constant, that went away. Okay, now remember, this only is because their question is take the derivative of an integral. If it just says the integral from 4 to 7 of 3 cosecant, I'm just making up whatever. Well, I'm not taking a derivative of anything. That's integrate a derivative. This is the other fundamental theorem where can I think of a function whose derivative is cosecant, and then I plug in 7, I plug in 4. No chain rule anywhere to be found there. You see what I mean? That's something totally different. This is because I'm taking the derivative of an integral. And this is because I'm integrating some derivative. Can I think of a function whose derivative is cosecant squared? Oh, sure I can. Hopefully you can. Cotangent, negative cotangent. And then I plug in 7, I plug in 4. No zeros anywhere to be found. No chain rule anywhere to be found. But this one, the chain rule is from the bounds up here. You see that? All right, let's go to, looks like problem 6.6, number 1. Let's try 6.6 just to get a feel for this type of problem. Find the average value. Okay, we want to find the average value of a function. Okay, now remember, refresh your memory. There's the average value of a function, and then the average rate of change of a function. Okay, now think about those two words there. The average value, we had to everybody see if you could find in your binder, average value. An average value is the integral from a to b of f of x dx. Add them up, average value, add up all the values, and then divide by a b minus a. There's the average value formula. When they say what's the average value as opposed to the average rate of change, get those organized together. Average value is the integral. So we have to integrate this. Oh, wait, there's a break in this. Okay, so what do we have to do? How do we integrate the integral from -1 to 1? We got to split that integral up. So the top is the integral from -1 to, well, let's show that step, of f of x dx divided by 1 minus -1. There's the, since they said between 1 and -1, there's the average value. Now, how are we going to integrate that with two different parts right there? Well, we have to split up the top. So the top now we have to integrate from -1 to 0, because then we're following this function, sine of x dx, minus, and then we pick it up from 0 to 1, and we follow this function, e to the -4x dx. All divided by 1, well, minus 1, so all divided by 1 minus -1, which is 2. Okay, one more time. Here's the average value formula. This is right there. Add them all up. That's a summation. Divide by b minus a. And so we're writing the formula. It says from -1 to 1. So a is -1, b is 1. Oh, wait, I cannot integrate f of x because it's a piece function. There's different pieces. From -1 to 1, I got to follow this function. So you see how I changed that. From 0 to 1, I got to follow this function. So from -1 to 0, I'm using this part. From 0 to 1, I'm using this one. Okay. Now, let's practice. How do we do that? Okay. Well, what's the integral of 1? X. What's the integral of sine? See, dramatic pause. The integral of sine is negative cosine, so that becomes +2 cosine of x from 0 to -1. And then here, chain roll. Maybe let's just show it, refresh your memory, a little u substitution there. Du dx is equal to -4. So we got an extra -1/4 in front there. Du equals dx. Just refreshing on chain rule right there. And you could finish that. There's a little hint on u substitution. Or you could have just done your calculator on that. Okay. Hunter, did that make sense? Do you see that thing, how we got to separate through on that? Let me know as I'm going to. Eric asked about 6.7, number 7. Number 7. Okay, so here's number 7. And, the table of data. This time we had data here on number 7. Okay, so let's see what it says. Let's see what we got to do. We got a little table of data. We got 7. Evaluate the integral from 0 to 1.5 of 3f prime of x plus 4 dx. All right. So what do we got to do here? First, properties of integration. Let's separate this. As soon as I see a binomial, as soon as I see plus, the very first thing I'm going to do is I'm going to separate this integral. 1.5 of 3f prime of x dx plus the integral from 0 to 1.5 of 4 dx. You see? Especially when you have stuff like f of x, the integral of f of x, can't do that yet. What about this 3? This 3 is times 3, so that 3 can come out in front. You see? All right, so what's the integral? This one we could do. Can I think of a function whose derivative is 4? Well, sure I can. 4x, 1.5 to 0. I plug in 1.5. 4 times 1.5, right? 6 minus 0. There's that part. That part is 6. Same question. Can I think of a function whose derivative is f prime? Well, sure I can. F. There's a 3 in front from 1.5 to 0. So this is 3 times f of 1.5 minus f of 0. Oh, wait, what's f of, oh, now I got to get the data. F of 1.5 is negative 1. So this is 3 times negative 1 minus 3 times f of 0 is negative 7. So what do we got here? I got 3 times negative 1. I got negative 3 plus 21 plus 6. And so what did I wind up with at 24. Let's talk through this one more time. Everybody take a look. The question was, what's this integral? Right? There's the question. What's that integral? So I used properties first. I separated the plus into two separate integrals. Always do that if you can't do it all at once. Like we didn't bother doing that for, where was that? We didn't bother doing that for this one, okay, because I knew what the integral of 1 is. I know what the integral of that one is. But when you see f of x and stuff like that, yeah, you should try to separate it and make life easier for you. Even take that 3 out so it doesn't get in your way. So look, I asked the same question. Remember, this is different than what we started with. I'm not integrating, I'm not taking the derivative of an integral. I'm integrating some derivative. Can I think of a function whose derivative is 4? Yes, I can, 4x. So I did that. Okay. Can I think of a function whose derivative is f prime? Yes, I can, f of x. So I did that. You see that? And then I plugged in the number. Now, how do I evaluate this? Well, that's why I was given a table of data. Who was that? Eric, your question? Did that make sense there? And Hunter said, let's do number 11. This is good as long as you're looking through these. Okay, so 11, we got a cubic, x cubed. All right, give some information. Okay, so it says if the integral, okay, if the integral from 0 to 1 of f of x dx is 32, what's the value for k? Well, let's see what we got here. F of x is equal to the integral from, well, let's just put f of x is 4x cubed plus ax squared plus bx plus k. Squeeze that in there. Okay? Now, what did they tell me? They told me the function has a local minimum at negative 1. What does that mean? What does that mean? When x is equal to negative 1, what should be happening? Okay? What should be happening here? When x, it says a function has a local minimum at negative 1. What does that tell you? You have to translate that to say when f prime of negative 1 should be 0. That's translated. A function has a local minimum at negative 1, that the derivative is equal to 0 at negative 1. The graph has a point of inflection. What does it mean, a point of inflection? Same idea. F double prime, a point of inflection at negative 2, f double prime of 2 must equal 0 also. You see, you got to translate that from the problem. Why do I need that? Because we're trying to solve for k here. That means we better know a and b. There's 3 unknowns. We better have 3 equations. Look, we do have 3 equations. So I know, let's see, f prime of x is 12x squared plus 2ax plus b. When I plug in negative 1, I better get 0. So I get 0 is equal to 12 minus 2a plus b. Second derivative I'll put over here. F double prime of x is equal to 24x plus 2a. Remember, x is the variable, a is just a constant. When I plug in negative 2, I should get 0. 24 times negative 2 plus 2a. You see what I mean? And, well, that's easy. We can solve for a. This is 48. Move it over there, divide by 2. A is equal to 24. A of a is 24. We got to go over here. Minus, let's see, 48 plus b. Well, that's B is equal to 36. So we got A and B. You see that? Take a look at that. A lot of work there, a lot of algebra work there. And now we go back to the integral from 0 to 1 of 4x cubed plus 24x squared plus 36x, still plus k. We haven't solved for k yet, but we know that's equal to 32. Sorry, keep my head on the camera. So we integrate. Add 1 to the power, 4x, so x to the 4th, cubed, so 8x cubed, squared, 18x squared, plus kx, evaluated from 1 to 0. I plug in 1 plus 8 plus 18 plus k. I plug in 0 must equal 32. Look at how we're on the home stretch now. And what do we wind up with here? 927 plus k is equal to 32, so k is 5. Let's talk through it one more time from start to finish. All right, the problem said, there's the translations, there's the function. The problem gave us the function. This is a good problem. It gives us the function right here. It said there's a local minimum at -1. You got to translate that. What does it mean to have a local minimum at -1? Right there. The derivative at -1 is 0. It has a point of inflection at -2. What does that mean? The second derivative. Points of inflection are with the second derivative. The second derivative at -2 is 0. So we get the first derivative, plug in -1, I should get 0. All right, that didn't get me anywhere because I had A and B. Second derivative, I take the second derivative, plug in -2, I should get 0. Okay, there we go. That helped me find A. I plug it into this one, 2 equations, 2 unknowns. I find B. And then I plug all that into this one to get the function. Still has a k in there, though. And so I integrated this, just good old power rule. Plugged in 1, plugged in 0, supposed to equal 32. It got me down to k is equal to 5. Take a look at that. All right. Okay, so let's back to the first thing. Remember, at 1 o'clock today, okay, at 1 o'clock today, so let me put it down, 1 p.m., I will post a problem, post an AP problem. Yeah, a 25-minute one I think a longer one. I'll post an AP problem. And I will also post the Zoom. I'll post the Zoom code. And at 1:30, we'll get on Zoom. We'll get online. We'll talk to each other here. And we'll see how you did. We'll work through the problem. Okay? That's the plan. Anybody feeling pretty good? Now, remember, if you're still stuck on something, on Thursday, I'm going to put the answers up, but you still post. You still say, hey, Mr. Noah, let's work on this problem for Friday. But let's try today. This is Wednesday. Let's try today and see how we're doing on that. Okay? Does this make sense? Anybody say anything? So, okay, we'll try it. Let's see who shows up. I hope everybody shows up. Everybody, tell your friends. Ran, tell your friends. Mark, tell your friends. Who else have we never seen still in existence? Tell your friends to be here. Okay? All right. I will see you later. It's getting a little rowdy upstairs. I better go help Mrs. Noah out. Talk to you later.